Hey guys, welcome to the 2015 Algebraic Methods Level 2 paper. So for this particular video, what I would recommend you to do is pause at the start of each question, try the question by yourself with the answers, and then check my working to see whether you got the same answer as me or not. What I'll also be doing is giving you guys what you need to have done for Achieve Merit and Excellence. Cool, so let's get started. Okay, so the first question is find the value of log 2 of 1024. There's two ways of actually doing this particular question, and I'm going to show you guys both methods, even though this is just an achieved question. Now, anytime you see log 2 1024, when it's actually written in this particular format, what you can do is, in your calculator, you just basically just do it like this. So you just write down log 1024 divided by log 2, and you should get an answer of 10. That's basically it. If you were to do it the other method, I would do it like this: log 2 of 1024 equals x, and then from here 2 to the power of x is equal to 1024, and at this point you're trying to figure out 2 times what number, well, 2 multiplied by how many times by itself is equal to 1024, and you can say 2 to the power of 10 equals 1024, and therefore x is equal to 10. So that is to get an achieved grade. Next question. Okay guys, so for this one we can't actually do this in the calculator, but what we can do is we can actually look at the log rules. For example, we know that a of x equals to b, which means log a of b is equal to x. So what I would do is I would actually match this equation with these things here. So because I know that I can write this as log AB equals to x, what I can say is A is equal to 4, B is equal to 3w plus 1, and C, x in this case is equal to 2. So once I write it like this, then I know that ax is equal to b. So I can rewrite this now as 4 squared equals 3w plus 1. So solving this, I get 16 equals 3w plus 1. Rearranging it, 3w equals 16 take away 1. And what I have is 3w equals 15, and w equals 15 divided by 3, which equals to 5. So doing this gets you an achieved grade. Sorry, I keep forgetting to put it as A, not U. Okay, let's go to the next question. So similar idea, Luke says that the equation has only one solution. Is he correct? So what I'm going to do is I'm going to do the same thing that I did before, right? I'm going to put this as log A B equals x. So from here, I can see that A is equal to x, B equals 4x plus 12, and x equals to 2. So my equation is going to be a to the power of x is equal to b. So what I have is x squared equals b, which happens to be 4x plus 12. And at this point, what you should be seeing is you're trying to solve a quadratic. So we can rearrange this as x squared minus 4x minus 12 equals to 0. And then we factorize it. So two numbers that multiply to negative 12 and add to negative 4, that's going to be negative 6 and plus 2. Now we need to solve these two values. So we got x minus 6 equals to 0, or x plus 2 equals to 0. So in our first answer, we get x equals to 6, or x is equal to minus 2. Now, here's the thing though. When we actually go back to the question, we got log of x. Now that base has to be positive. It can't actually be negative. So what you have to say is that you have to say x has to be positive, because basis can't be negative, and therefore x is equal to 6 is only solution. Okay, in terms of grade wise, giving this reasoning and only one solution gets you an excellence. If you give both values, you're getting a merit. Setting up a quadratic equation, so possibly here, you're looking at an achieved for this question. Okay, let's go to B of this particular question. So we got make x the subject of the equation, a2x equals bx plus 1. So how are we going to do this? So we've got a to the power of 2x equals b to the power of x plus 1. Now, the first thing I would ask you guys to do is I would actually ask you guys to take logs of both sides. So we have log a2x equals log of bx plus 1. Now what we can do is we can actually bring the power to the front of the log. So we can rewrite this as 2x log a equals x plus 1 log b. Now I still need to figure out a way to separate that x plus 1 log b. So what I'm going to do is I'm going to expand the brackets. All right, and when I expand the brackets, I'm going to get 2x log a. That stays as it is. I'm going to get x log b plus 1 times log b is log b. Now remember, I want to have x by itself, so I'm going to bring this term here to the other side. So when I bring it to the other side, it'll become minus. So I'm talking about this term, become minus x log b, and that's still equal to log b. So at this point, what I can do is I can take x as a common factor, and I would have 2 log a minus log b equals log b. So now I can have x by itself, which means I'm going to get log b divided by 2 log a minus log b. All right, and for this particular question, guys, correctly solved to the end gets excellence. Takes logs of both sides and rearranges. I'll probably say somewhere around here will get you a merit, and multiplying by indices, so probably here gets you an achieved. All right, let's go to the next question. All right, guys, so for this question, we've got a market value of Sue's house. It's been increasing at a constant exponential rate of 3%. So the first thing is if something is increasing by a percentage, so we got increase by 3%, it's the same thing as saying multiply by 1.03. Something to keep in mind. Next thing it says is that she bought it 16 years ago at the start of 1999. At the start of 2015, it was worth $350,000. Okay, so the other information that we know is at the start of 2015, that means 16 years has passed. So we can see that t is equal to 16, and the value of the house is $350,000. So what I'm going to say is value of the house is $350,000. Now the question it's saying is that assuming the exponential growth is in the form of this particular equation here, what was the value of the house at the start of 1999? So what we're looking for is we're looking for the value of A, because that's the price of the house at the start of 1999. So let's see what are all the components we actually have. So we need to do y equals ART. We know that when t is equal to 16, y is equal to 350,000. We also know the rate, which is 1.03. So it's just a matter of putting this all in the equation, guys. So we got 350,000 equals A multiplied by 1.03 to the power of 16, which means solving this, A is equal to just a matter of dividing 1.03 to the power of 16. And when you do this, you get a value of $218,108. So basically, we're saying that initial price is $218,108. So in terms of grades, we have got merit for this particular question. Setting up the model, I think setting up the model isn't achieved. Wow, really? I guess you get an achieve just for doing this part here, just setting up the model like that. That's a pretty easy mark to get. Anyway, let's go to the next question. All right, so what we have is a friend also bought a house at the start of 99 that cost 200,000. So they were paying 1.035 T. So that's how much it was increasing by. It's given by the fire. And if the houses continue to keep increasing in the values of the original rates, in which year will the two houses be worth the same amount? Okay, so we have Sue's house, which is Y. I mean, we kind of calculated it from the previous question, is that Y is equal to 218,108 multiplied by 1.03 T. That was Sue's one. And while, as for her friend, it's going to be Y is equal to 200,000 multiplied by 1.035 T. And what we're trying to figure out is at what point will the two houses be the same price. So what you have to do is put the two equations equal to each other. So you have 218,108 multiplied by 1.03 T equals 200,000 multiplied by 1.035 T. So rearranging this, you got 218,108 divided by 200,000 is equal to 1.035 T divided by 1.03 T. Now, what you can do is, because there are T's in the numerator and denominator, we can rewrite this as 1.035 divided by 1.03 and put a big bracket around it with a T there. And as for this, will become 218 divided by, well, 218,108 divided by 200,000. We've got 1.0905. So at this point, guys, you need to take logs of both sides to actually work this out. So this will look like ln of 1.09505, equals ln of 1.035 divided by 1.03 to the power of t. And now we can bring the t in front, so we're going to get ln of 1.0905 equals t multiplied by ln of 1.035 divided by 1.03, which means t equals ln of 1.0905 divided by ln of 1.035 over 1.03, and what we should end up with is t equals 17.89. Now, if it's 17.89, you need to actually make sure you mention which year it's going to be to finish the question. So we're going to say in 2016, the prices are going to be the same. Okay, and that's what's going to get you an excellence. Solve for a t, that part only gets you a merit. Setting up an equation, that right there is an achieved. All right, that's basically question 1 done, guys. Now we go to question 2. Okay, so question 2, we got a simplifying equation here. Now, for the numerator, you've got to factorize it. Just a suggestion, guys. If you don't know how to factorize it, what I would do is I would actually put 2x squared plus 7x minus 4 in your graphics calculator and get the two solutions. When you get two solutions, what will happen is it'll give out two solutions. One solution as -4 and the other solution as +0.5. Now what you can do is, this is a trick that I use for you to factorize the numerator if you're unsure. What you do is you basically go x equals -4 and you rearrange it in a way so that one side equals 0. So in this case, you're going to get x plus 4 equals 0. And on the other one, you've got x is equal to 1/2. So rearranging this, rather than doing x minus 1/2, I'd actually go cross multiply. So I've got 2x equals 1 and then 2x minus 1 equals 0. Now what I've done is I've actually factorized this quadratic here. So the top here, I can rewrite it as x plus 4 multiplied by 2x minus 1. And as for the bottom, I've got 2 multiplied by x squared minus 16. And I hope you guys can see that this is a difference of 2 squares. So we're going to get x plus 4 multiplied by 2x minus 1 divided by 2 times x plus 4 multiplied by x minus 4. Now at this point, you can cancel out 2x plus 4's, and your final answer is going to be 2x minus 1 divided by 2 times x minus 4. Okay? Now it's also good to kind of indicate just a little note for you guys, just to put on the side there, x is not equal to plus or minus 4. The reason is, if you go back to this original equation, if you put x equals to 4, then that function is going to get divided by 0, and therefore it doesn't actually exist. And same with negative 4, because negative 4 squared is 16, 16 times 2 is 32, and 32 minus 32 is 0, so you can't have that. So just kind of keep that as a separate note there. All right, so in terms of grades, merit for this part here, factorize and simplifies with one error. So somewhere here, if you factorize it and you simplify with a minor error, you get an achieved. Okay, let's go to question 2b. All right, so what we have is we've got if a equals y to the power of 3, 4, find an expression for a to the power of 7. So if you have a to the power of 7, since a is equal to y to the power of 3 over 4 to the power of 7, then this could be written as y equals 3 over 4 times 7, and which would be 21 over 4. That's basically it, guys, for this question. Nice and little neat achieved there. Okay, let's go to question C. Now, this is one of my favorite questions. You might be like, what the hell is wrong with you? Yeah, I know. The reason why this is one of my favorite questions is because a lot of people see this thing and they start doing things with exponents. What if I told you that this is actually a quadratic? All right, and I think what's a really good idea to do is whenever you get a question like this is to observe two things, particularly the powers. I'm talking about the powers. Observe the powers and see what you notice. What I can see here is 2/3 is actually 2 times 1/3. All right, and that should give you an indication of that this, what you're working here, is actually a quadratic. Because watch what I do. I'm going to call x is equal to u to the power of third, which means x squared is going to equal u to the power of third to the power of 2, which can be written as u to the power of 1/3 times 2, which is replaced with u to the power of 2 over 3. So because of that, now I can rewrite this equation as 2, because u to the power of 2/3 is x squared, I'm going to write that as 2x squared plus 7 times u/3. u/3 is equal to x, 7x equals to 4. So at this point, I can rearrange this, and I'm going to get 2x squared plus 7x minus 4 equals to 0. And this should look familiar because this was a question that we actually did earlier in question 2a. And if you're not sure, just put on a graphics calculator and get the two values and rearrange as usual. So what we have is 2x minus 1 multiplied by x plus 4 is equal to 0. Therefore, we can say that x is equal to a half, or x is equal to -4. Now, we're not done here. What we need to do, though, is we need to solve for u. So we go back and we substitute it into x equals u/3. So we've got half is equal to u to the power of third. So to figure out u, I need to cube both sides, because when I cube both sides, I get u and 1 cubed over 2 cubed, which is 1 over 8, as one of my answers. My second answer is going to be -4. So I've got -4 equals u to the power of third. So I've got to cube both sides again to get what u is. So I'm going to get u is equal to -4 cubed, and -64 equals to u. So those are my two answers, and so get an excellence for the two u's. If you got up to x's, then you get merit. Rewriting as a quadratic gets you an achieved. All right, and that's how you do this question, guys. Let's go to the next one. Okay, so Talia uses timber to form an exterior sides of a rectangular garden. Just going to draw a quick rectangle here. The length of the garden is x meters and the area is 50 meters squared. Show that the perimeter of the garden is given by 2x plus 100 over x. Okay, so what I'm going to do is I'm going to call, obviously I'm going to need a second side here. So I'm going to have this rectangle with sides x and y. So I can say that area equals x multiplied by y equals 50. So what I can do is I can rearrange it as y is equal to 50 over x. So the next step is perimeter of the garden. Now perimeter is going to be 2x plus 2y. So perimeter is 2x plus 2y. Because if you think about it, I've got x in the bottom, I've got x at the top, I've got y on the right side, y on the left side. So 2x plus 2y. Now I know y is equal to 50 over x, so I can rewrite this as 2x plus 2 multiplied by 50 over x. And what I end up with is 2x plus 2 times 50 is 100 over x. And that's my proof right there. Get an achieved for that question. All right, let's go to part 2 of this question. Part 2 of the question, it says, if she uses 33 meters of timber to build the sides, find the dimensions of the garden. What we do know is we know the perimeter is equal to 2x plus 100 over x. And now we're saying that the timber that she's using is 33 meters. So we got to figure out the dimensions of the garden. So we basically got to solve this equation. The way I do this particular question, the easiest way to do this is the way to get rid of that x at the denominator is multiply every term by x. And when I multiply every term by x, I've got 2x times x, which is going to equal 2x squared. 100 over x multiplied by x is just going to become 100. 33 times x is going to become 33x. And what you should see is you've got a quadratic that you can actually rearrange. So you're going to get 2x squared minus 33x plus 100 is equal to 0. So at this point, guys, you can factorize this, or you can put it directly in the graphics calculator and get your two solutions for x. So when you factorize it, you get 2x minus 25 multiplied by x minus 4 equals to 0. So at this point, you've got 2x minus 25 is equal to 0. So 2x is equal to 25, and x is equal to 25 over 2, which is 12.5. Or you get x minus 4 equals to 0, x is equal to 4. Now, here's the thing. Using this, you could actually go back and try and work out what the y value is. But just remember, when she actually uses 33 meters of timber, you could potentially get this. You could get a shape like this, or you can get a shape like this. It's still going to have, both of these things are going to have 50, right? I guess what I want you guys to see is, like, for one example, see how this is 12.5 and then this is 4. But if the area is 50, 50 divided by 12.5 is 4, and 50 divided by 4 is 12.5. So the dimensions of the rectangle, dimensions of garden is 12.5 meters multiplied by 4 meters. So this gets you an excellence. This just gets you a merit, just solve for x. Forming a quadratic equation gets you an achieved. All right, so that's all the way up to D, guys. Now we have a look at question E. So with E, this is what happens. It says David and Sione are competing in a cycle race of 150 Ks. Sione cycles on average 4 Ks faster than David and finishes half an hour earlier than David. Find David's average speed. So the first thing I'm going to do is I'm going to put David's speed here. Okay, David actually, his speed, let's call it x kilometers per hour. Sione's speed will then be x plus 4 kilometers per hour. Now this is an interesting question, right? Because I mean, you're trying to figure out what David's average speed is. But the one thing that you know is he's finishing half an hour earlier than David. Now I want you guys to have a look at this, all right? The hint is average speed equals distance over time. So we know that velocity equals distance over time. But the only clue that we have is that one of the guys finishes half an hour early. So what we need to do is we need to rearrange t in terms of d and v. Okay, that's because if we take David's time and we subtract it from Sione's time, we're going to get 0.5. Okay, because so if we take David's time, so David's time minus Sione's time, we're going to get 0.5. But for David's time, what we do know is his distance that he travels is 150, and the speed that he goes in is x. And I guess that's why I wanted you guys to see that time is equal to distance over velocity. Minus, Sione still travels 150 k's as well, but the speed he travels in is at x plus 4. And now this is equal to 0.5. So this is what our equation is, and now we need to actually solve this, guys. So the way we're going to do this is, as I said to you before, if you want to multiply, get rid of things in denominator, multiply everything by the same term. So what I'm going to do is I'm going to multiply first everything by x. And when I multiply everything by x, what I'm going to get is 150 over x times x is just 150, minus 150 times x over x plus 4. I can't really do anything with that, so I'm going to write it like this. Equals 0.5 times x is just going to be 0.5x. Next, I'm going to multiply every term by x plus 4. And multiply this also by x plus 4. So what I'm going to end up with is 150 multiplied by x plus 4 minus, now here the two x plus 4's kind of cancel out each other and I get 150x is equal to 0.5x multiplied by x plus 4. Now what I need to do is expand the brackets. So I've got 150x plus 600 minus 150x equals to 0.5x squared plus 2x. So rearranging this, I've got 150x and 150x disappear, and what I'm left with is 600 equals 0.5x squared plus 2x. Bringing this to the other side, I get 0.5x squared plus 2x minus 600 as a quadratic. Now guys, when you put this in the calculator, you should actually get two answers. X equals plus or minus 32.7, but obviously we can't be using the negative version of this answer, so we're going to be using positive version of this answer. So x is equal to 32.7 kilometers per hour. Okay, so grades wise, getting the final answer gets you an excellence, sets up equation correctly. I think this one right here is going to get you a merit, and solves with an error. Okay, so you got to solve with an error, so it kind of carries on with some of the stuff here. Cool, that's it for this question, folks. We go to the next question 3. Okay, question 3, what we have is simplify giving your answers with positive exponents. So what we have is we've got something with negative exponent. So straight away, I'm going to flip the whole equation upside down. So this would become 4a5 over a to the power of 10 to the power of positive 2. Okay, and the next thing I'm also going to do is, because I've got a5 and a10, I'm going to rewrite it as, because a5 divided by a10, it's going to be rewritten as a to the power of 5 in the denominator, and that's raised to the power of 2. So this is going to become 4 squared divided by a to the power of 5 times 2, and what you have is 16 divided by a to the power of 10. And guys, this gets you a grade of an achieved, no, I'm sorry, that actually gets you a grade of merit. Whoops. Final answer gets you a grade of merit. And if you make a minor error, but you have like numerator or denominator correct, then you end up getting an achieved. Okay, let's go to part 2 of this question. So we got 32 over x to the power of 5 to the power of 3, and then the 5th root of that. So anytime you have that little 5 inside the square root symbol, we can rewrite this as 32 to the power of x to the power of, 32 divided by x to the power of 5, and the whole thing to the power of 3 divided by 5. Okay, that's where that 5 actually ends up being. So now when we expand this out, we're going to get 32 to the power of 3 over 5 divided by x to the power of 5 multiplied by 3 over 5. Now 32 to the power of 3 over 5, if you put it in the calculator, you should get 8. And 5 times 3 over 5 is just 3. So this will become x to the power of 3. So grades wise, merit for this part. And as usual, numerator or denominator correct will get you an achieved. All right, let's go to question B. Question B says, solve the following equation for t. Okay. Now, what I'm going to do is, with this particular question, looking at the denominators, if I make all the denominators the same, then I can just say the numerators are equal as well. So what I'm saying is, let's make, because if you look at it, t times t minus 1 is what we have here. We've got t here, we've got t minus 1 here. So what I'm recommending is that we convert this denominator t to t times t minus 1, and this denominator t minus 1 with multiplied by t. So basically, do something like this. So you've got 1 over t times t minus 1 minus 1 over t equals 3 over t minus 1. So remember I said I would like to make the denominator t times t minus 1. So in this case, I'm going to multiply the denominator by t minus 1, but I've also got to multiply the numerator by t minus 1. And as for the next case, I've got to multiply the denominator by t and the numerator also by t. So what I've basically done now is I've actually got all the denominators as the same, which means the numerators has to equal each other. So that means I would have 1 minus 1 times t minus 1 equals 3t. And from here, I can rewrite this as 1, expand the bracket, I've got minus t, negative times negative 1 is plus 1, and that's equal to 3t. So what I have is 2 minus t equals 3t, 2 equals 3t plus t. Carrying on, I have 2 equals 4t, and t equals 2 divided by 4, which means t is equal to a half. So grades wise, merit for this. And it says partially solved by rewriting over correct common denominator. So basically going somewhere here and doing, I guess, a half job. That's what gets you an achieved. Okay, let's go to question 3c. Okay, so 3c says, for what values of k does the graph of the quadratic function never touches the x-axis? Now, if you guys remember back from discriminants, for the quadratic to never touch the x-axis, b squared minus 4ac has to be less than 0. So that's what we're going to be working with. So we've got a, in this case, equals to 1, b equals to 3k minus 1, c equals 2k plus 10. So what we have is b squared minus 4ac has to be less than 0. So let's replace b now. So b will become 3k minus 1 squared minus 4 times a is 1, c is 2k plus 10, and this has to be less than 0. So the first thing I'm going to do is I'm going to expand the brackets of 3k minus 1 times 3k minus 1. And on this side, I've got minus 4 times 2k plus 10. And all this still has to be less than 0. So expanding this quadratic, I've got 9k squared minus 6k plus 1 minus 4 times 2k is 8k minus 4 times 10 is negative 40, and that has to be less than 0. So simplifying this, I've got 9k squared minus 14k minus 39 has to be less than 0. So at this point, guys, what I would say is try and factorize the two equations. Sorry, not the two equations, just this equation. When you factorize this equation, you're going to get 9k plus 13 multiplied by k minus 3. And that's what my for the quadratic equation is. So I'm going to put this as equal to 0, which means 9k plus 13 equals to 0, or k minus 3 is equal to 0. Now, in the first instance, k is equal to positive 3. In this case, 9k equals negative 13, and k equals negative 13 over 9. But remember, this is a quadratic, and we want to find out when this quadratic is less than 0. So I want you guys to actually picture this particular quadratic here, not this one, but this one, 9k squared minus 14k minus 39. If you were to draw this particular graph, it's going to look something like this. And we got these two values here. One value is going to be 3. The other value is going to be minus 13 over 9. And the question says, when is it going to be less than 0? It's going to be less than 0 in this particular zone here. So our final answer for this question is going to be minus 13 over 9 less than k less than 3. Now you can't put equal to, because if you put equal to, then that means you've actually got you're actually working out for one root. So be very careful with that one, okay? And that's basically your final answer. So that gets you an excellence, that gets you a merit. So please, guys, just remember, anytime you're working with this particular discriminant questions, it's going to have something like this, and it's best to draw this diagram just to see where it is. Also, to get an achieved for this question, I think in the answer schedule it actually says discriminant is less than 0. I think even if you just write this part here, by the looks of it, it looks like you're getting achieved. That's an easy achieved. But anyway, that's what you need to do for this particular question. Alright guys, so for this particular question, I've got mx squared minus m plus 2x plus 2 equals 0. It has two positive real roots. Alright. There's actually two ways to do this particular question. But I'm actually going to show you guys the real quick way of doing it first, which is if it has two positive real roots, all right, that means it's actually cutting it, well, positive real roots. Oh, sorry. Let's try this again. That means the quadratic is going to look something like that. Okay? What we do know is if it has positive real roots, then b squared minus 4ac has to be greater than 0. So that's what I'm going to do. I'm going to do b squared minus 4ac is greater than 2. So I've got negative bracket m plus 2 whole squared, that's what b is, minus 4 times m, because that's what a is, multiplied by c, which is 2, and this has to be greater than 0. So when I expand this bracket of m plus 2 squared, I'm going to get m squared plus 4m plus 4 minus 4m times 2 is 8m. And that is greater than 0. So simplifying this, I've got m squared minus 4m plus 4, and it has to be greater than 0. So what I can see is it's a nice perfect square. So I can actually factorize this to m minus 2 squared has to be greater than 0. So, and I think this is where you can actually write the reasoning, guys. M actually can be any number. Okay, because you know that any number, when you square that number, it becomes a positive, whether it's negative or positive. So m can be any number in this case, except 2. M can't equal to 2, because if m equals to 2, then 2 minus 2 is 0, and you can't say that 0 is always greater than 0. Okay, and so this is how you prove that m actually can be any possible number except 2. So this is one way of doing it. And I think if you do it this way, you end up with, the same thing. You get an excellence for this. Getting to this point, you get a merit. And achieved is this point here. So this is one way of doing it. The other way of doing this question is by using the quadratic formula. So we know the quadratic formula is minus b plus or minus b squared minus 4ac over 2a, because that's what the solutions for x is going to equal. So negative b means you've got negative m plus 2 plus or minus b squared minus 4ac. Do I really have to do it? Because I've already done it on this side here, guys, but I'm going to show you anyway, all right? So you got negative m plus 2 squared minus 4 times m times c, which happens to be 2, divided by 2m. So what you should end up with is positive, because the two negatives there, it converts to a positive. So we got m plus 2 plus or minus square root of m minus 2 squared, because that's what I ended up doing here, divided by 2m. So I've got m plus 2 plus or minus, now square root of m minus 2 is just, m minus 2 squared is m minus 2, divided by 2m. So my first solution is going to be m plus 2 plus m minus 2 over 2m. And my second solution is going to be m plus 2 minus m minus 2 over 2m. So solving this, I've got m plus m is 2m. 2 minus 2 is 0, and that's divided by 2m. So one of my solutions is 1. And my second solution is m minus m is 0. 2 minus minus 2 is 4 over 2m. And this could be simplified as 2 over m. So what you can say with this particular method is you've got to actually say that m can't equal to 0, because if you have m equals to 0, this particular solution will not work. You've also got to mention that m can't equal to 2. Because if m equals to 2, then you're only going to get one solution. I'm talking about here, because remember, if m equals to 2, that actually becomes 0, and you only get one solution, and you need to have two real roots for this particular question. So that's another way of doing this same question, guys. Excellence for the bottom part. Both roots found gets you a merit, but for the excellence, you need to mention that m can't equal 0 and m can't equal to 2. All right, so that's basically it for this particular session. So thank you guys for watching. If you have any questions, pop it in the comments below. Please don't forget to like and subscribe, and also don't forget to share with other people. That's it from me for this session. As usual, thanks for watching.